What's poppin', dogs? Mr. Allen here. We are evaluating some limits given a graph in this video. And I'll tell you what, the limit of our mathematical fun that we're about to have in this video does not exist, or maybe even approaches infinity. I don't know. Let's get it going. So for the first one here, we got the limit of f of x as x approaches -1 from the left. That second negative right there means from the left, from this side. So let's see here. This is -1. So as I approach -1 from the left, I'm on this part of the graph here. Looks like I'm approaching 1, 2, 3, 4, 5. -5 would be my answer for this one. Cool. So from the left is this. From the right is this. It would have been -3 from the right. If we get asked that later, cool. If not, whatever. All right. Next one. The limit of f of x as x approaches -6 from the right. Okay, so -6 is right here. 1, 2, 3, 4, 5, 6. And from the right would be, again, this stretch actually, but just coming from the other way. I'm approaching, it looks like, -3. Cool. How about the limit of f of x as x approaches 6, +6? Now, this one doesn't say from the left or from the right, so we have to assume it's both, right? We have to see it from both sides. And if they both agree, then it has a limit. If they're at different spots, or they're, whatever, then it does not exist. So let's go over to 6 here. 1, 2, 3, 4, 5, 6. I am approaching the same value from the left and the right. Even though the function value is different right now, I'm still approaching the same thing. So the limit does exist, and it is 1, 2, 3, +3. All right, how about the limit as x approaches 3? That we got, let's see here. It's not even like really a point that I plot. Well, it just went through perfectly, yes. So I'm approaching 3, my x value of 3 from the left and right. It is 0 because it's going to the same spot right there. Dope. Okay. We're cruising, man. We're cruising. I got to calm down. I'm just having a lot of fun. All right. The limit as x approaches -6 from the left. So from the left, we'd be over here, and we are approaching -6. We're going up to, let's see here, 1, 2, 3, 4. So my limit would be then 4 as we are approaching -6 from the left. Okay. How about just the limit of f of x as x approaches -6? Just -6, right? So it's got to be the same thing from the left and the right. Well, I've already basically got this taken care of. I don't even need to look at the graph. I can see from the right, it's -3. From the left, it's 4. We can also see that on the graph that they're approaching different things. Therefore, it does not exist for that one. They got to be approaching the same thing from the left and from the right for that limit to exist. All right, cool, awesome. Up top here, limit of f of x as x approaches -infinity. So as I go to the far left side of the graph, it looks like we are approaching an asymptote. Sometimes I'll plot them in there so you know that it's an asymptote. So it looks like we're approaching +1 as we go to the far left-hand side of the graph. Now, how about what's f of 6? So this is just asking for the straight up function value. So this is like Algebra 1 type stuff, but we sometimes get so lost in the mathematical sauce of this new concept that then you're like, I can't even just look at a graph and see that. Well, f of 6 is 0, right? That's the point here. Although my limit as f of x as x approaches 6 is 3, my limit was 3, right? The graph from left and right is approaching this 3. The function value, this is a hole right here, the function value is right here at that solid point, which is 0, okay? It's one of those, little things we got to notice as we practice these limits, okay? So they will throw that type of question at you, especially they might be leading you into some of those where they'll be like, what's the limit as x approaches 6 from the right, from the left? The limit as x approaches just 6. And you're like, oh, it's 3, it's 3, it's 3. And they'll be like, what's f of 6? You'll be like, whoa, it's 0, okay? So be careful. F of -6. Well, our limit as x approaches -6 does not exist, but the function value does. It's right here. It is -1. So even though the limits are approaching different things from left and right, my function value is still just that guy right there. The same would have gone if even if say that was a solid dot, then I would have just picked this value here, okay? So wherever the solid dot is, that's the function value, if that's the situation you're dealing with. All right, how about, let's see here. The limit as f of x limit of f of x as x approaches -1 from the right. So from the right, whoop, looks like we're at -3. What is f of -1? So this is actually the situation I was just talking about. Okay, so f of -1, my solid dot is here, was on this stretch here. Doesn't matter that the limit is approaching the same thing. It's because I have a solid dot here that I get 1, 2, 3, 4, -5. Okay, so wherever that solid dot is, that's the function value. Whereas with this one, it was 2 holes, and the dot was just kind of chilling on its own. Here, it is at the endpoint of one of those stretches of this like piecewise function that we're dealing with here. All right, looks like our last one. I got them all over the place on here for all the mathematical fun. And I did try to mix them up so we don't get into this little groove of analyzing them, because on your test, these types of questions are going to be all mixed up. On worksheets, we'll often go through like the limit as x approaches -6 from the left, from the right. What is it? Does not exist. What's the function? And they'll just systematically go through it. I wanted this more like random, all right? Last one, as x approaches infinity, it looks like as we go to the right, this guy is just going up. There's no vertical asymptote here to tell me anything else, so we'll go ahead and say infinity. Some folks will also just say does not exist. Because you can't really get to infinity. I feel like that's a hotly debated topic. If it's just one stretch of the graph there, I think it's fine to put infinity. But a lot of times if you're dealing with asymptotes, then they're talking about, if they're approaching different things, does not exist. Even sometimes when they say they're both approaching the same thing, they say that it does not exist, or positive infinity. So kind of a weird spot there. Make sure you talk with your teacher, see what they want. I'm going to go with infinity for this one because I'm the teacher in this one. That's what's up. All right, you guys have a great day. Thanks for watching.